Hello and welcome to Chapter 9, Section 1. Here we are identifying quadratic functions. We've been working with quadratic equations and on how to factor them, so we're very familiar with them. Any function that can be written in standard form, which is y equals ax squared plus bx plus c, where a does not equal 0. So there is an x squared in there somewhere. That's a quadratic function. And you need the y equals part to make it different than all of the work we've been doing in chapters 7 and 8. If you were to graph this function, it graphs in a parabola. And a parabola looks like this, where it's not a V shape, there is some curve to it, and there is one point that is the lowest point on the line, and that's called the vertex. Or it can be the highest point on the curve as well, depending on whether A is positive or negative. In Chapter 5, we learned to find a common difference in functions. So for example, if we were just looking at y equals 2x, a very basic linear function, we put in x, which is 0, 1, 2, or 3. It could be, it keeps going. And if we put 0, 1, 2, or 3 in for x, we end up with y as 0, 2, 4, or 6. And so when we got y, we realized in a linear function that each of the y's went up by a common difference, the same number. And that number we actually could see here. So when you work this out, you come to realize that, oh, I just have to look at the equation to see what the common difference is going to be. In a quadratic function where y equals x squared, there's another layer. So when we put in 0 through 4 for our x, and we find x squared, or solving for y, we end up with 0, 1, 4, 9, 16. And the first difference that we find, 1, 3, 5, 7, and we see the pattern here. And the second difference is the squared part. If the second difference is constant, then the function is quadratic. So you've got to go through 2 layers to find a common difference for quadratic functions. So your first set of questions is going to ask you whether each function is quadratic. And so you're going to put in your x's, you're going to get back y's, and you're going to come up with the first difference and the second difference. And if the second difference is all the same number, it doesn't have to be 2, it can be 4, it can be 5. In fact, the example on page 610, example 1a, the difference is all 4. And that's because they're all 4, it's a common constant difference, so it's quadratic. So you have 2 types of questions that your homework is going to ask you. It's going to start, and the question is tell whether each is quadratic, but it's going to give you a series of points. So you're going to have x's and y's, and it's going to just give you equations. And our job is to figure out if each one is quadratic. So if you're given points, you need to put the points in a chart like this, so that we can set it up. Because what we're doing is we're looking for the common difference, and we know we're going to have to go through 2 layers. So the difference here is 6, the difference here is 2, 8 minus 2 is 6, 2 minus 0 is 2, 0 minus 2 is negative 2, and 2 minus 8 is negative 6. So 6 minus 2 is 4. 2 minus negative 2, that's 4, minus negative 2. And negative 2 minus negative 6 is 4. So here's our common difference. So the answer to this is yes, and the common difference is 4. Here we have a quadratic equation where and right away we can see that there's no ax squared. We have to have an x squared for it to be a quadratic equation. And this one doesn't have it, so the answer is no, because a equals 0. And a cannot equal 0 in a quadratic equation. It has to have an x squared. Here we have y plus 3x squared equals negative 4x. Well, if I subtract 3x squared from both sides, I end up with y equals negative 3x squared minus 4. Yes, this is a quadratic equation because it can be written in the form y equals ax squared plus bx plus c. Here, b actually happens to equal 0, but that's okay. So you've got 3 different types of issues here. See if you can walk through, check it out, numbers 1a and b on the top of page 611. Pause here and come back when you're done. So for number 1a, I put all of the points in a chart, and we found the first difference, and then we found the second difference. And yes, this is a quadratic function because it has a common difference of 2. In B, I rearranged, I subtracted x from both sides. Y equals 2x squared minus x. That answer is also yes, because it can be written in this format, and a does not equal 0. So the next thing we have to decide is how to graph a quadratic function into a parabola. It's not a V-shape because a V-shape is absolute value. I'm going to ask you to use graph paper because this can get complicated and it's really easy to get off. And what I remember about the last time we had to graph parabolas is that you did them very freehand, and then when it came time to the test, you lost a lot of points. So we want to be specific. Not because I'm being picky, but because I am preparing you for high school, and high school is going to be picky, so you need to get good while the points don't matter as much. So we're going to start by making a table of values where x equals all of the numbers right around 0. Negative 2, negative 1, 0, 1, and 2. So here I've pulled out my graph paper, and we're going to make a table of values for the equation y equals 2x squared. So we're going to input these for our x, and we're just looking for y's. So we're going to say 2 times x is negative 2, so x squared is 4. 2 times negative 1 is 1. 2 times 0, 2 times 1, and 2 times 4. So we've got 8 and 2 and 0 and 2 and 8. And 8 minus 2 is 6, and 2 minus 0 is 2, and 0 minus 2 is negative 2, and 2 minus 8 is negative 6. And our second one, 6 minus 2 is 4. 2 minus negative 2 is 4. Negative 2 minus negative 6 is 4. So we've got a common difference. So we know that they're probably right because that makes it a quadratic function. Now that we've made sure all of this, we've got our points, negative 2 and 8, negative 1 and 2, 0, 0, 1 and 2, 2 and 8. And we're going to graph those. 0 and 0, 1 and 2, 2 and 8, negative 1 and 2, negative 2 and 8. And when we graph this, we're going to make sure it comes down in a curve. This is not a point, it's a curve. Those are the 2 examples, and then they ask you to go through and check it out. Number 2, there's 2 to do there, and you'll actually have a C attached. So make sure when you're doing your calculations, you do them correctly. You graph the correct numbers, and you can see how C alters a graph. Okay, pause here, do those two, come back when you're done. So here we have 2a, which is y equals x squared plus 2. So we've graphed our world here, and we have our x's and our y's, and we go ahead and graph this, and we realize that c, which is plus 2, brought our parabola up 2 spots. And then it looks just like the parabola did before. For y equals negative 3x squared plus 1, so we've made our calculations. We've got our points. A is negative, so it's facing downward. C is plus 1, so the vertex goes up 1, but it still is pointing down. Okay? Please make sure you ask any questions if you have any issues with this. The next thing this chapter talks about is the vertex of a parabola. It is the minimum or maximum y. It's either the lowest or the highest point on the parabola, and that's the single point. It doesn't have a pair like every other point on a parabola does. It's got a left and a right. So here, if the vertex is 0, 4, then the maximum your y, remember y goes up and down, the maximum your y can ever get is 4. There's nothing that's ever going to let y be bigger than 4 because it goes up to 4 and turns right around. Here, when your parabola opens to the top, it's going to go up infinitely, and the minimum it's going to be is negative 2. So the next set of questions this chapter is going to ask you is to find the domain and the range. Now remember, domain is the x and range is the y. And domain, when you're looking at a graph like this, domain is going out like this, the x's. Now if you took this parabola and you went infinitely higher, eventually this would get infinitely fatter, which means it has the potential to take in all real numbers. So when you have a parabola that opens up or down, your domain is going to be all real numbers. All real numbers. It's the range that is going to have limitations. For this parabola, the range is going to be y is negative 2. It's going to be equal to negative 2, or it's going to be bigger than negative 2, because that's our minimum. Here, our y is going to be equal to 4, or it's going to be smaller than 4. So we want the small side on the y, smaller than 4. So our range is always going to look like an inequality problem. So the first thing you need to do when it says find the domain and range is to find the vertex, because you know what the domain is, and the range is going to tell you about your y. If your vertex here is 3, 4, your domain is going to be all real numbers, and your range is going to be equal to 4 or smaller than 4. And you can tell that just by looking at it and knowing what this point is. So go ahead and pause here with this information and do check it out, numbers 4 and 5. We skipped 3 because we already talked about it and it's stupid. So check it out, numbers 4 and 5 will do all of this information for you. Pause here, come back when you're done. So question 4 asks you for the vertex, and it asks you for the maximum or minimum value of y. So here I've drawn the vertex for 4a and 4b. I've drawn the parabola. The vertex here is negative 2, 5. The vertex there is 3, negative 1. And I've identified the maximum and the minimum. Question 5 asks you to take it that step further and give the domain and the range. So the domain for both of them is all real numbers. The range here is greater than or equal to negative 4, and the range here is less than or equal to 3. Please ask if you have any questions but this is all pretty introductory, get to know your parabola kind of questions. So you're looking at page 614, numbers 24 to 60, every third problem. All right? Let me know if you have any questions, and I'll see you tomorrow.